Hello everyone. This video is brought to you by Newton's group of institutions. I am Arvind Egreddy from the Department of CSC. In this video, I'll be talking about flowcharts. In our previous video, we have discussed about algorithms. And in our next video, we will be discussing about the pseudocode. If you like my videos, please subscribe to my channel and press the bell icon to get the latest updates. Now let us see what is a flowchart. The first design of flowchart goes back to 1945, which was designed by John von Neumann. Unlike an algorithm, flowcharts uses different symbols to design a solution to a problem. So it is another commonly used programming tool. By looking at a flowchart, one can understand the operations and sequence of operations performed in a system. So flowchart is often considered as a blueprint of design used for solving a specific problem. So a flowchart is a visual representation of an algorithm. A flowchart is a diagram made up of boxes, diamonds, and other shapes connected by arrows representing the order or link among the different steps. Here, the operations to be performed is written inside the box, and all symbols need to be connected by arrows among themselves to indicate the flow of information and processing. Now, let us see the different advantages of flowcharts. A flowchart is an excellent way of communicating the logic of a program. Flowchart is easy and efficient to analyze problems using flowcharts. During the program development cycle, the flowchart plays the role of a blueprint, which makes the program development process easier. And after successful development of a program, it needs continuous timely maintenance during the course of its operation. So the flowchart makes program or system maintenance easier. It is easy to convert the flowchart into a program by seeing the flowchart. So here, what we can say is a flowchart can easily explain the program logic to the program development team. And a flowchart is useful to prepare the detailed programming documentation. And the flowchart details help prepare efficient programming code. So here, the flowchart helps detect and remove the mistakes in a program. And the flowchart is useful to test the logic of the program. So by writing the flowcharts, there are so many uses. And at the same time, while drawing the flowcharts, we need to follow certain rules. So we need to use consistent methods in drawing a flowchart, and we need to use common and easily understandable words while drawing the flowchart, and we need to use consistent words or names in the flowchart. We need to avoid cross flow lines in the flowchart, and we need to draw the flowchart from top to bottom and from left to right. So flowcharts that exceed the page should be properly linked using the connections to the portions of the flowchart on different page. So these are the rules what we need to draw or what we need to take care while drawing the flowcharts. Now, let us see the different symbols what we are using in drawing the flowcharts. So there are some standard symbols to draw the flowcharts. Some of them are here, and first symbol, that is an oval or a terminal symbol, which is used to represent the start and end of the process. And the next symbol, that is the rectangle symbol, represents any step in the process of our diagramming, and it is the workhorse of the flowchart diagram. So we use rectangles to capture the process steps like tasks or actions in our process. And the diamond symbol indicates a decision. That is, it symbolizes that the decision is required to move forward. So this could be a binary, this or that, or to choose or more complex decisions with multiple choices. So here we need to make sure that we capture each possible choice within our diagram. Then coming to the fourth symbol, the parallelogram symbol, which shows where and how the data is coming in and going out throughout the process. So it also called as a data symbol. So this parallelogram shape is used to input or output the data. And the arrow indicates the directional flow. So the arrow is used to guide the viewers along the flowcharting path. As we know that the flowcharts are made up of sequence of actions, data, services, and or materials. So they illustrate where the data is being input and output, where the information is being stored, what decisions need to be made, and which people need to be involved. So in addition to the basic flowchart conventions, rules and symbols, we have some more flowchart symbols which will help us to describe our process even more detail. So here we see different shapes of symbols for documenting symbols, data symbols, input output symbols, merging and connecting symbols, and additional use shapes. So these are the different shapes and symbols in addition to the standard symbols we will be using while drawing the flowchart. Now let us see the algorithm and flowchart. So here let us write an algorithm and flowchart to find the sum of the two numbers. So here I have written the algorithm on my left hand side and I have drawn the flowchart for the same in the right hand side. So if I can see, we have written the algorithm using 6 steps. So here there are 6 symbols. So using these symbols, so start and stop, starting and ending is represented by the symbol oval shape, and input and output we need to represent by using parallelogram. That's the reason we have taken here input value of A, input value of B, and output is sum. And whatever the process we are executing, that we need to show with an rectangle symbol. So this is the simple way of writing an algorithm and a flowchart. Now let us see an next example of writing an algorithm and flowchart. So here I have written an algorithm and flowchart to convert the temperature from Celsius to Fahrenheit. And here if you can see, we have done this we have written this algorithm in 5 steps. So here we have 5 symbols. So first one is start and the last one is stop. Starting and ending symbols are being represented with an oval symbols, and input the temperature in Celsius. So here this is an input and we are displaying the output Fahrenheit. So these are input and output symbols. That's the reason we have represented these symbols by using parallelogram. And here we are processing, we are calculating, we are taking the Celsius temperature and we are converting it into Fahrenheit. So it is a process. So the process is being represented by using the rectangle symbol. So this is how we can write the algorithms and flowcharts. Thank you. Thank you very much.